So it's just going to fly. The rest of this semester is going to be gone in a hurry. All right, we are moving on to section 4.5. And guys, 4.5 and 4.6, we spend a lot of time on these. We spend a total of 5 days on these two sections, 5 teaching days. All right, and if you don't stay on top of this, it just explodes out of control because they build every day. I show you a little more, and then the next day we add a little bit to it, and the next day we add a little bit more to it. So these get, if you don't stay with me and don't stay on top of your homework, then it gets a little bit tricky for you really quick. So make sure you're staying on top of stuff as we go through 4.5 and 4.6. Okay. All right. So section 4.5. Finding solutions and zeros. Okay, finding solutions and zeros. So, do you guys remember the zero product property? Oh, yes, you do. Okay, if I have two things multiplied together, if I have A times B equal to 0, what can you tell me about one of them? That should be equal to 0. What can you tell me? One of them is equal to what? 0. Well, what if I have A times B times C equal to 0? What are you going to tell me? One of them has to equal 0. So the zero product property just says if you factor something, you just take all your factors and set them equal to 0. We're going to do that for higher degree polynomials today. So as you look at example 1, read the directions. The directions say to what? Solve. We are going to solve, and the method we're going to start by doing is by factoring. So what is my first rule of factoring that I can apply to this big polynomial? Justin. What's the first rule of factoring?
GCF.
GCF. Do you have a GCF?
2.
What'd you say?
Yeah.
Yeah. What's your GCF?
2x.
2x. So when you factor out a 2x, what do you have left?
X squared minus 6x plus 3. Oh, wait. Sorry. No.
There you go. All right. Now what's left is a trinomial. A is 1. Life is easy. What question do you ask yourself?
Well, multiplies to give me 9, adds to give me negative 6.
And what would that be?
Negative 3.
So you just write x what?
Minus 3.
And x?
Minus 3.
Okay. Are we done factoring? Could you guys factor that pretty simply? Mm-hmm. All right. Now, remember when it says solve, you then have to take each of these factors and set them equal to what? So we're going to set 2x equal to 0. We're going to set x minus 3 equal to 0. And the other x minus 3 equal to 0. When you do, what do you do to solve this first one? We can solve this. We have an x. What do? Divide by 2. And when you do, you get x is what? What do you do here? Add 3. And what do you guys get for this one? X equals 3. What do you get here? Do you get the same thing? So your two answers are x equals 0 or x equals 3. Thoughts on this first one? Did you solve it? Yep, you're done. All right, let's go to the second one. Okay. Cash, what's my first rule of factoring? Do you have a GCF? 5x. So when you pull out a 5x cash, what do you have left? Okay. Now you have a trinomial. What question do you ask yourself? So what multiplies to give you 16 and adds to give you negative 8? Negative 4 and negative 4 multiply to give you 16, add to give you negative 8. So what does this factor into? And then what? Okay. Now be careful. Remember our directions once again said to solve. So when you set each piece equal to 0, what do you get on this piece? x equals 0. What do you get on this piece? And this would be the same. So here's your two answers. All right, I want to add one more factored already so that you guys can see just for a minute. Okay, if when you factor, you get this. Okay, let's just say when you factor, maybe you had a factor by grouping. Okay, however you factored, you ended up with this. Can you factor x squared minus 2 any further? No. So what would we do then? We'd set each factor equal to what? 0. Now, what do you do to solve this one? Subtract 3. And when you do, what do you get? X equals what? Negative 3. What do you do to solve this one? Add 2. So you get x squared equals 2. And what do you do now? Take the square root. But when you take the square root, what do you have to remember to put out front? Plus or minus the square root of 2. So there is one like that tonight. I just wanted to make sure you guys knew how to finish it. Are you good there? Yep. Okay, so first part of your homework tonight just says solve. You're going to factor them. Set each factor equal to 0. Use the zero product property. Are we good? Okay. Well, there is something here called a repeated solution. Did we have a repeated solution? Yeah, we had 2 repeated solutions there. Okay. And when you have a repeated solution, something special happens to the graph. Okay. If it has an odd number of times that it is repeated, okay, it kind of bends at the x-axis. If it is an even power, it will touch and go up. So let me show you once with this. I'm going to put this graph. You guys can just watch. You don't have to put this in your calculator. I'm just going to put 2x to the third. You can just watch this. Minus 12x squared plus 18x. And I'm going to go zoom 6. And we're going to take a look at this graph. And you can see that my solutions, remember, the solutions, the zeros, the roots, they're all going to be the same thing. This is which one? 0. And what's this one? Well, 1, 2, 3. So does my graph show that it's at 0 and 3? Okay. The only thing is, notice right here, it comes and it touches and it goes back up. The reason it does that is because how many 3s did I have? 2. Okay. So sometimes in an old textbook that I taught out of, it would say with a multiplicity of 2. That means that this occurred how many times? Twice. So if the graph has an even multiplicity, it touches and goes back up. So one way I tell my students to remember this, if you graph y equals x squared, you know what that looks like. What's it do? It touches at 0, 0, and it goes back what? Up. If you were to let this find the 0, let y be 0, it's 0. What about this one? What do you guys think y equals x to the third does? Do you guys know what that shape looks like? Have we learned that enough yet? Does it go down? Do you guys remember it kind of comes and it bends right there and goes up? Do you remember how it bends right there? So an odd multiplicity is going to bend at the 0. Even multiplicity touches and goes up or touches and goes back down. Okay? So that will help us. That will help us when we go to sketch graphs. This will be a no calculator graph. Okay, so we are going to do some things. It's going to be no calculator part, and this is a no calculator part. Find the zeros. Okay, what do we do when we find the zeros? We just let f of x equal what? 0. Okay, so we're going to come in, and we're going to let f of x equal 0. And it says find the zeros. Remember, the zeros are the same thing as the solutions. first rule of factoring, since that's the only way we've done them right now, is GCF. Does this one have a GCF? Oh, yeah, it does. What is it? -2. So when we pull out a -2, and you're pulling out a negative because the leading term is negative, what do you guys have left? X to the 4th. What would I have left here? Minus 16x squared, and then what here? I'm sorry. Yes, minus 8x, and then what? Plus 16. I'm so focused on the sign, I forgot to take out the 2. Okay, so now redistribute, make sure that works. -2x to the 4th plus 16x to the 2nd, and then minus 32. Okay, now I have a trinomial. A is 1, life is easy. Can I factor it if the degrees go 4 to constant? What multiplies to give you 16? That adds to give you, what multiplies to give you 16 that adds to give you -8. -4, -4. But what do I put on the front ends? X squared and x squared. Ooh, am I done factoring? No. What does x squared minus 4 factor into? So this would be x plus 2x minus 2. And this one factors into x plus 2x. Whew. Have I fully factored? Does anybody have any questions on that? Okay, now when I set my pieces equal to 0, remember when you set -2 equal to 0, do you have anything to solve there? In these ones, be careful, we had 2x equal to 0 or 5x equal to 0. So we had something to solve for. This one, we just have -2 equal to 0. That goes away. So what do you guys get here? X equals what? -2. How about here? 2. How about here? -2. And how about here? 2. So you could say that x is equal to -2 or x is equal to 2. Those are my two answers. You could also tell me that x is equal to -2 and x is equal to 2 with a multiplicity of what? 2. They occur twice. Okay, now I'm not going to ask you that, but you need to know that for the graph, that they occur 2 times. Because that's going to be important when I come here to my graph. So I'm going to come over here to 2. I'm going to put x-intercept. I'm going to come over here to -2, and I'm going to put an x-intercept. And I know because it has even multiplicity, it's either going to touch and go up or touch and go down. Well, let's talk about the end behavior of my graph. This was on your quiz last week. Does it have even or odd degree? What is the degree of this polynomial? 4. So it's even. Okay? So both the ends go in what direction? Same or opposite? Same direction. And do they both go up or both go down? Because the leading coefficient is... So we know it's going to do something like that. We're not quite sure what, but we know my ends are both going down. So we're going to keep that in mind. We're also going to think about the y-intercept. What would the y-intercept be? Wow, how'd you get 0, -32? Oh, you let x be 0. They all go away. What's left? -32. Okay, so let's go ahead. What scale do you guys want to go by here? I'm going to go like -10, -20, -30, -40. Can I do that? Sure. And then -32 would be about right there. So can we see the shape of our graph? We know the ends have to go down. We know it's going to touch and go down. It's going to go through the y-intercept. It's going to touch and go down because at my x-intercepts, they have even multiplicity, so it will touch and go back down. And there's my graph. Now we keep getting a little more that we're learning about these graphs to make them more particular each time. Questions thus far? You guys good on A? All right, let's take a look at B. What is my first rule of factoring, Chloe? GCF. What's your GCF? Oh, we're finding the zeros, so what are we going to let f of x be? 0. And let's go ahead and take that x out. When you do, what do you have left? Now you have a trinomial. A is 1. Life is easy. What question are you going to ask yourself? And what multiplies to give you -6? It adds to give you +1. Close. How about -2 and +3? Because a bigger one has to be positive. Does that make sense? Okay. So now, Chloe, when you set each of these equal to 0, you're going to set x equal to 0, x minus 2 equal to 0, and x plus 3 equal to 0. What are your x-intercepts or your zeros? Perfect. How'd you guys do at solving it? Now, put those on your graph. They cross the x-axis at 0, at -3, and at +2. What's the x-intercept on this one? Careful, it has an x with it. Let x be 0. What do you have left? 0. So the y-intercept is 0. The y-intercept is at 0, 0. Perfect. All right. Well, let's go ahead then and talk about end behavior. Even or odd? Odds, they go in opposite. And does it go up to the right or down to the right? So we know that the ends go this way and then like that. So we know it has to come up like this. Has to go down through here and then up like here. We still haven't talked about our local maximum and local minimum, so we don't know how high or how low those humps go yet, but we're still getting through the graph. So we do not have any multiplicity, so nothing bends, nothing touches and goes back up or touches and goes back down because every 0 occurs one time. No graphing calculators on those. Are you guys cool with that? All right, now for 1 minute, I want to talk about your number system, okay? You have real numbers, and real numbers consist of numbers that are rational. What are rational numbers? Numbers that can be written as a fraction. For example, 5 can be written. How do you write 5 as a fraction? 5 over 1. 1/2. That can be written as a fraction. 0.3 repeating. Any repeating decimal. What's 0.3 repeating? 1/3. Any decimal that terminates. 0.25. What would that be? 1/4. Okay. So any decimal that terminates, stops, repeats, any number that's already a fraction or any whole number, those are all rational numbers. Then we have real numbers that are also irrational. These are still real numbers. They're just irrational. They can't be written as a fraction. Pi, square root of 2. Those are irrational numbers. But they're still real. In order to be a non-real number, what does it have to have in it? What's our non-real numbers have in it? An I. Good, Jordan. An I. Okay, so 5i, 2 plus 3i. Those would be non-real numbers. Anything that has an I. Okay, square root of -5. Because would that end up having an I in it? Those are all non-real numbers. Because sometimes when we start this section and we start talking about find all real numbers, people get this and they're like, oh, that's not a solution. I'm like, it's a real number. Square root of 2 is a real number. So the first theorem we talk about today is what's called the rational root theorem. And the rational root theorem says, okay, and it's basically right here. If you have any polynomial of any degree, when my board jumps like that. If you have any polynomial of any degree, the possible rational roots are P over Q, where P are the factors of the constant, and Q are factors of the leading coefficient. So P over Q, possible rational roots, factors of the constant over factors of the leading coefficient. So, our first two examples. Find all real solutions. Okay? We had some earlier and we factored them. I'm looking at this and I'm saying, do I have a GCF that I can pull out of all four of these? I have four terms. Okay, I could pull an x squared out of here and I'd be left with x minus 8, but what do I do there? Can I make them the same? So can you factor this by our traditional factoring methods? We cannot. Okay, but we can still solve it. We can still solve it. So the first thing I'm going to do, and at the beginning, when I do this right now, you're going to be confused as to why I'm having you do P over Q. This is one of those things that as we make these more difficult, you're going to see why I'm making you do P over Q. Okay, so let's just practice P over Q. P is factors of my constant. What is the constant? So 20 divided by factors of my leading coefficient. What's my leading coefficient? Okay. So what are the factors of 20? Well, I could have plus or minus 1 and what? 20. I could have plus or minus 2 with what? 10. Does 3 go into 20? Does 4 go into 20? How many times? And then once you meet like 4 and 5, you're done. So there's my list factors of 20. What are the only factors of 1? All right. And then you have to put each of these over 1. You have to put 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10. Well, anything divided by 1 is just what? Itself. So your possible rational factors are, or rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. So these are the possible rational zeros. That does not look like possible. Okay, possible rational zeros. Now, when I was in school a million years ago, we didn't have graphing calculators. So we would have to check and see if these were a zero. Now, if they're a zero, they're an x-intercept, they're a root, they're a factor. How could I check that this is a factor of that polynomial? Not plug it in for us. Synthetic division. So I had to just start with one of these numbers and pray that I got a 0 for my remainder. And you just kept going down that list until you got 0 for your remainder. You guys have a graphing calculator. So I told you guys to get those out at the beginning of class. Let's get those out. And let's type in x to the third minus 8x squared plus 11x plus 20. Okay. And I'm going to do a zoom 6 because I don't know what my window was the last time I graphed, although I just graphed it in class, but you didn't. And here is your graph. So I'll give you guys a minute to see if you got this. Did you guys get that? So where do the zeros appear to be at? So the zeros appear, and that word is really important, appear to be at what? Well, what number would this be? If your scale, remember, I did zoom 6, I did standard window, negative 10 to 10 by a tick mark of 1. So what does that number appear to be? Negative 1. And then this would be 1, 2, 3. This would be what? 4. And this one would be what? Are those in my list of possible rational zeros? Okay, so that's good, right? That's good. I at least got the ones in my list of possible rational zeros. And now we're going to test one of them. And it does not matter which one you start with. So, Jack, we're going to use synthetic division. Which one do you want to test? Negative 1, 4, or 5? Okay, and since it says x equals negative 1, what are you going to put on the outside? Well, but it says x equals. So do you put, since it says x equals, don't you just put negative 1? Okay, and then the original polynomial, does it have any holes? I'm looking way up here. I have x to the third minus 8x squared plus 11x plus 20. So what do you put inside here?
1, negative 8, 11, 20.
Okay, now if this is a factor, a 0, a remainder should be 0. So let's see what you get, Jack. Let's go ahead, pull the 1 down, multiply, you get what?
Negative 1.
Add.
Negative 9.
Multiply.
9.
Add.
20.
Multiply.
Negative 20.
Add.
0.
Okay, so is it a factor? You guys know from geometry, just because it looks like it's a negative 1 doesn't mean that it is. We just proved that it is. Now, this is where we did that problem last week. What is the factor? If x is equal to negative 1, what's the factor? Do you remember? This is where you got to bring it back over. So it'd be x what, Jack?
X
Plus 1. And now, since you started with x to the third, this tells me how many x. Gotta go down in degrees.
to the x squared.
Okay, so this is 1x squared. Then what?
Minus 9x plus 1.
And this was equal to what? 0. Ah, now I got a trinomial. Is that trinomial easy to factor? A is 1. Life is easy. What multiplies to give you 20 that adds to give you negative 9, Jack? Multiplies to give you 20 and adds to give you negative 9. It's a form of those.
4 and 5.
But they'd have to be what? Negative 4 and?
Negative 5.
Oh, snap. So what does x equal when you set each of these equal to 0? What do you guys get? Negative 1, 4, and what? 5. Now, guys, don't cheat yourself and skip this step. Because what's going to happen is this is going to become not factorable, and you're going to have to use quadratic formula to get your rational solutions or imaginary solutions. These are going to keep growing. So don't skip out on this step while it's easy. Okay, let's try one more. All right. Do our traditional factoring methods work? No. So let's do P over Q. just to get used to it. P over Q. Factors of what over factors of what? 24 over, okay, do we even need the 1 in this case? No. So what are your factors of 24? I'm just going to put plus or minus out front. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay, so is there your possible rational zeros? So this list here is my possible rational, that means can be made into a fraction, zeros. Okay, what do you do next? Can't factor it, so what do we do? How do we find out which in this list is really going to work? Plug it into your calculator. X to the third plus x squared minus 14x minus 24. Graph. Okay. There's that. And here's the graph. All right. So where do the zeros appear? All right. What is this number? This is what? -3. What else? -2. And 1, 2, 3, what? What else? 4. All right, let me pick somebody that wants to choose which one they want to pick. Doesn't matter. She's out taking her test. So, hey, Addie, which one do you want to pick?
-2.
-2. Smack dab in the middle. All right, what goes on the inside, Addie?
1, -14, -24.
And remember that said x equals -2, so I put the -2 out there. Let's go ahead and do the math. Bring down the 1, multiply,
-2.
add,
-1.
multiply,
2.
add,
-12.
multiply,
24.
add.
0.
Okay. So now, what are my factors? This becomes a factor of what?
X plus 2.
X plus 2. What's left here?
X plus 2.
Careful, we started with x to the what?
Oh.
Third.
X squared. Minus 1x. Minus 12.
A is 1, life is easy. What multiplies to give you -12, that adds together to give you -1. So, careful, I got your signs wrong. It'd have to be -4 and +3, right? Multiply, give me -12, add, give me -1. And now, what's this solution?
-2.
What's this one?
4.
And what's this one? Is that what we thought they were going to be? Guys, you have to show that work. If you don't show that work, you're setting yourself up to make the next couple sections very difficult. All right, homework.